We are on page 45. We are still talking about surface area. Hooray, you were afraid we were done with it. Not quite. But now we're talking about the surface area of pyramids. Now, good things to know. Good things to know is that surface area is still surface area. It's the outside surface, the area that would be painted. You know how to find the area of triangles and squares, which is all you need, and you know what a pyramid is. So theoretically, without me even saying anything, you might already know how to do this. Imagining you don't, the good news is we also have nets for pyramids. Now in this net, you'll see that the four shapes are together, the four triangles are together, and this was a square pyramid, so the square is off on its own. A lot of times in the nets, we see that the base is in the middle and the triangles are all attached here. But this brings up a really good point that there's not just one right way to draw the net, that there can be lots of different ways to draw the same net with the same surface area. So much like last time, we have 3 layers of being able to find the surface area of the net. The first one is just like before. They give us a grid paper net, and we have to be able to count the squares in that of a net, like whether the net looks like that or whether the net looks like what I just showed you, which was, I think it was like that. Okay, either way, same shape. I'm not going to bore you because I feel like after seeing the last 2 videos, you maybe don't need level 1 demonstrated. But move on to level 2, which is they show you the net and they give you the dimensions. So and we're going to start with square pyramids. So let's say that we have a 3 by 5 square pyramid. So we know we're drawing this pyramid, we start with a square, we find a point where everything's going to meet. This is a square pyramid because it has a square base. And they're going to give us the net. They're going to show us that this falls apart to be a 5-inch by 3-inch square on the bottom, and that each one of these sides is 5 inches tall? It's 5 tall. The height is 5. Okay, so we start, the square in the middle is a regular old rectangle, square, either one is fine, thank goodness, and that is 15 inches squared. So that's the area of the base. Now we have these 2 triangles right here that have the same width and the same height. So they're going to end up having the same area, which makes sense. So they have a base of 3 inches and a height of 5 inches. But remember that whenever we're finding the area of the triangle, we're finding 1/2 of the base times the height. So in this case, I am going to say, all right, what is 1/2 times 15? Whenever I multiply fractions, I can pretend there's an imaginary 1 on the bottom. I do 1 times 15 is 15, 2 times 1 is 2. 15 halves, written as an improper fraction, or written as a mixed number, would be 7.5 inches squared. And that is the area for both of these. So I have 2 flaps that are 7.5 inches squared each. Then I have these guys, which are also triangles, but they have a slightly different size to them because they have 5-inch bases times 5-inch heights. So when I do 1/2 times 5 times 5, I get 1/2 times 25, which I can put over 1. 25 over 2 reduces to 12.5 inches squared. And again, I have 2 of them. I have this one and that one. So now it's time to add things up. I have 7.5 plus 7.5 conveniently makes 15 inches squared. 15 inches and 15 inches squared makes 30 inches squared. These two together make 25 inches squared. So 30 plus 25 inches squared means the surface area of this square pyramid is 55 inches squared. And our last level, of course, like last time, is being able to just look at the 3D figure with dimensions, not having the net. Oh man, I got all my marker caps mixed up. It is a whole hot mess over here. Okay, so if I have, it's going to be 2 feet on the bottom. So the nice thing, it's actually truly a square pyramid, not like the weird one I gave you last time. And it is 3 inches tall. And that is on all sides because they're all the same height. All right, so attack it. Again, it helps to have kind of an order to the madness. So I always start with the base. The base in this case is a 2-inch by 2-inch square, so it has an area of 4 feet squared. I know you can hardly see that. Thank you for your patience. All right, good news. The other 4 sides will all be identical, so I can just find the area of one of those sides and then add it up 4 times. So the area of any of these sides is going to be 1/2 times 2 times 3. Base times height. I know 1/2 times 2 is 1 times 3. 1 times 3 is 3 feet squared. So that means that every single one of these sides has an area of 3 feet squared. This one, this one, this one, and this one. So when I add up 3 plus 3 plus 3 plus 3 through my 4 triangles plus 4 for my square on the bottom, this equals 12 plus 4 is 16 feet squared. There we go.